In today's lesson, we'll be learning about angle relationships in polygons. Polygons are shapes with three or more sides. However, regular polygons are special. For regular polygons, all sides are equal and all interior angles are equal. And you can see that indicated with these little symbols here. We'll be referring to regular polygons here and there. As you can see, here is a polygon, more specifically a triangle, and its exterior angles are all labeled. If you recall, the exterior angles of any triangle must add up to 360 degrees. As you can see here, we have another polygon, more specifically a square. All of its exterior angles are also labeled. A square is considered a type of quadrilateral since it has four sides. And if you remember, the exterior angles of any quadrilateral must add up to 360 degrees. Over here, we have another polygon, more specifically a pentagon, and its exterior angles are all labeled. Based on what we've seen earlier, will the exterior angles of a pentagon also add up to 360 degrees? Let's see. 72 plus 72 plus 72 plus 72 plus 72 gives me 360 degrees. Therefore, I think it is safe to conclude that the exterior angles of any polygon must add up to 360 degrees. However, this only works for convex polygons. I'm not going to go into that right now, but all of the polygons you'll see from me will be convex polygons. In our first example, we have a polygon, more specifically a hexagon. We need to determine this unknown exterior angle. Based on what we just discovered, we know that the exterior angles of any convex polygon must add up to 360 degrees. I can represent this as an equation. I've gone ahead and written this out as an equation. Next, I'm going to identify like terms. 70, 65, 45, 70, 65, and 360 are all like terms. I'm going to collect like terms by bringing all of these terms to the other side of the equation. And when I do so, they are no longer positive, they become negative. Now that I've collected like terms, I can simplify the right side of the equation, and that is going to give me 45 degrees. Therefore, x is equal to 45 degrees. In our second example, we are once again given a polygon, more specifically a hexagon, whose exterior angles are given as expressions and not actual numbers. Again, we can use a relationship that the exterior angles of any convex polygon must add up to 360 degrees. I'm going to be representing this as an equation. I've gone ahead and written this as an equation. At this point, you can identify like terms. 2x, 3x, 5x, 2x, 3x, and 5x are all like terms. Meanwhile, 30, 30, and 360 are like terms. I'm going to be collecting like terms by bringing this 30 and this 30 to the other side of the equation. When I do so, they are both no longer positive, they become negative. I'm going to simplify the left side of the equation, which becomes 20x, and the right side of the equation simplifies to 300. I'm now going to solve this equation by dividing both sides by 20. Those 20s are going to cancel out, and x is equal to 15.